CSCI 201. Okay, the first thing we need to do is create a screen rectangle, set its coordinates to 50, 50, 700, and 380. Display with a different color than the background, and keep all sprites on this area and everything that we do below. Okay, that's pretty easy to do. So I've got a blank program here. I haven't imported any content yet. The only thing I've really done is I've deleted those extraneous comments at the beginning of each one of our methods here. So we need a screen. A screen is a rectangle. And we need to initialize it, which is something we've been doing all semester long, pretty much. And I want it to be 50, 50, 700 wide, and 380 tall. That'll give us a 50 pixel border all the way around. And I'm going to need some content here. I'm going to pause the video for a minute, go get some rectangular content, and I'll be right back. Okay, I've got a white rectangle that I've pulled in here for my content. And now there's two things we need to do. We need to load it. So screen. Whoops, I need a, in addition to a rectangle, I need a texture. 2D. Okay. Now, screen texture equals content dot load, and it's going to be texture 2D, and it's going to be rectangle white. Okay, and then down here we need to draw it, and so we need a sprite batch dot begin, and we need a sprite batch dot end, and then in between we need to draw a rectangle, our screen rectangle, and the texture is going to be screen texture, the rectangle is going to be screen, whoops, and we'll do it red for now. See how that looks later on. And let's just go ahead and run the program, and we should have red rectangle on cornflower blue with a 50 pixel border all the way around the outside eventually. Okay, and it took a while, but there it is. So that takes care of the first step. Now let's go back over here, and we want to position a sprite that's square. We want to move it in response to the left thumbstick. The height and the width should be 10% of the screen. Okay, so I just need a sprite that I can move around. That's 70 by 70. Okay. Okay, and I need to find something, so let's go out here, and I'll actually keep the video running on this one. So I need to get an existing item, and something that's relatively square. Well, we could do that. Obviously it's not square, but it's the rectangle that it would be displayed in would be square. Yeah, let's do Elvis. So that already is square. It's 300 by 300, and I need a few things for Elvis. I need a Elvis texture, and I need an Elvis rectangle, And let's do the rectangle down here. Elvis rectangle equals new rectangle. And for right now, I'm just going to do 0, 0 for the location, and we'll fix that later. And the width is going to be times, what did I say, 10%? Yes. So 0.1 F, and actually it doesn't really matter because whether I put the F there or not, because it's still, I'm putting this in a rectangle and all the parts of a rectangle have to be in, so I still have to do this. And make sure you put the parentheses around the whole thing there, otherwise it'll take the int of the screen width and then multiply by a floating point, and we'll still get an error. So I want to take the int of the whole thing, and in general that's probably what you want to do, put parentheses around the entire expression. And then I want another int that is going to be the same value. And then I want to read it in, so Elvis equals load texture 2D, and it's Elvis. Okay, and now let's flip back over and see what else we have to do here. Should move it in response. The origin should be set to the middle of the image and make it rotate, set its initial position to the middle of the screen. Okay, so we need to, maybe I should have done a structure here, but I'm already into it, so we'll just keep going. So I need a vector that will be the origin, Elvis origin, and we also, I think that might be all. So after we read it in, the origin is relative to the original picture. So Elvis origin equals new vector 2, and the x value is going to be Elvis texture dot width divided by 2, and the y value is going to be Elvis texture dot height divided by 2. Okay, and that'll set the origin, which is just, you know, the location on the picture that we're going to use to position it. I also need to initialize the rectangle, so let's do that here. I need to put them in the center of the screen. And I can't do that with a rectangle. I'm going to have to use the other draw method, which means I need a whole bunch of stuff. So actually I think I'm going to backtrack a little bit here, and I probably should have specified that in the problem description, but that's okay. So I want a struct and let me see, I need a texture 2D, and these all need to be public as well. And then I need public, what else do I need? Okay, I cheated. I went and copied the sprite struct declaration from another location. So this is what I probably want to do for Elvis. So let's go back here and delete this, and let's delete this, and let's delete this. Okay, and then let's declare a sprite struct called Elvis. Okay, and now Elvis dot let's skip that. Let's go down here and do Elvis dot texture, and we'll load that. And Elvis dot origin is going to be Elvis dot texture and Elvis dot texture. Okay. The Elvis, let me see. We can do dot position equals new vector, and I want it to be the x coordinate to be the middle of the screen, which is going to be screen dot left plus screen dot width divided by 2 and divided by 2, and then screen dot top plus screen dot height divided by 2. Okay, and the Elvis color is going to be white. Elvis dot rotation is going to be 0. We'll start off with him straight up. And Elvis dot origin, and that's the one we're going to have to wait on because we can't figure that out until we've actually read everything in. Elvis dot scale is going to be have to done after we read it in. Elvis dot sprite effect is going to be sprite effects dot none, and Elvis dot layer depth is going to be equal to 0. Okay, so I've done the position, color, rotation effects, and layer depth 1, 2, 3, 4, 5. That means I still have 4 more that need to be computed. And I'm reading the texture down here, and I'm computing the origin. And then the scale is the interesting part. Elvis dot scale is going to be, let me see. We know that Elvis is supposed to be 10% of the screen width, and so what I want is I want the width of Elvis to be the screen width times 0.10f, and that's how many pixels wide he will be, which in this case will be 70 pixels because our screen is 700. And now what do I have to multiply? Let's do a little algebra here. My scale, what do I have to take the original Elvis dot texture dot width times something equals, what do I have to multiply it by to get the screen width, that's 70 pixels, times 10%. Okay, and this is just simple algebra. Now I can take this over, divide by this on both sides, and if I go over here and do division, then that's my scale. So you don't really have to memorize that. It's not that hard to figure out. So now I've got, I think I'm missing one thing. I have the texture. I have the position. I have the source rectangle, and the source rectangle can be null if you want the whole thing. So I missed that one up here somewhere. So let's do Elvis dot source equals null. Okay, and now, oh, it's not going to let me do that. Okay. So we'll delete that, but you can pass in a null argument down here when it's time to draw it. So sprite batch. And we're doing the long one here, which I think is number 6. And so I want Elvis dot texture. I want Elvis dot position. I want Elvis source rectangle is going to be null. And Elvis dot color. Elvis dot rotation. Elvis dot origin. Elvis dot effects. Elvis dot layer depth. Okay. If I've done my calculations right, Elvis should be, and apparently I haven't done everything right. Where did I forget the semicolon? Okay. And now let's try to run it, and theoretically Elvis should appear in the center of the screen, and he should take up about 10% of the size of the screen, and I'm guessing that's pretty darn close to 10% of the size of the screen. Okay, and that's probably a good place to stop the video before it gets too long, and then we'll continue in the next video.